t sine 2t. Okay? So, just a note where all of this came from. This was the complementary function that we found early on. That is our particular solution that we just found, particular function, complementary function. Okay. So it's a process. It is definitely a process. What I have for you, it's not another quiz. Okay, but instead, it is a guide. Okay, so a way to choose the, so for instance, forcing function, and this is for non-homogeneous linear equations, and this is a list of choices. So if you have a forcing function that's cubic, for instance, the particular solution that we would try after this is after we find the complementary functions, so the solution to the homogeneous equation. The form of the particular solution that we would try is a cubic, a general cubic that has all the forms of its derivatives present as well. So ax squared plus bx squared plus cx plus d. Put that into the original differential equation, differentiate, you get this expression on the left involving those constants a, b, c, d. On the right, you have just your function, and you equate coefficients of like terms, right? So to solve for those parameters, a, b, c, d. So the same thing could be done with a polynomial of degree n, right? We probably won't go too high. If you have a forcing function of the form cosine, you just try cosine and sine, any multiples of those, because after that, repeated differentiation just gives you another cosine ax, another sine, cosine, sine. So you only have to stop until you cover all the forms of the derivative. Okay? E to the kx, try a e to the kx, and if these, remember, if these are covered already in the complementary function, we tack on a power of x. Tack on a power of x out front like we did in the previous example, in this example, until it is no longer within the span. I don't want to use that word because it's not later on in the class, I don't know what that is, but until it's no longer a linear combination of the complementary functions. Okay. All right. So I want you to try a couple. We won't be able to do all of these, but this is something you can also work on as well for practice over the weekend. So try a couple of these in group 1. So it also has steps 1 through 3 where it says, you know, look for the first forcing function term, write its particular solution. If it's present in the complementary solution, multiply this entire thing by x. If it's still present, multiply by another x. Repeat until that sort of escapes any linear combination of the complementary function.
Should we take our break now?
No breaks.
No break.
Let's do this. It'd be a nice transition. We'll work on this for 10, 15 minutes, 10 minutes or so. We'll take a break.